The purpose of Lab 4 was to analyze the motion of a spring mass that swings in an arc while oscillating on a spring. I compared the motion in the video to the model from Python using the energy principle and Newton's second law. The results of this lab was that the predicted motion of the mass represents the actual motion of the data in the video. Newton's second law will be used to find the final velocity so the final position of the mass can be found. The energy principle says that the change in energy is equal to the sum of the change in kinetic energy, potential energy of the spring, and the potential energy of the gravitational force. I put the video into Tracker to analyze the actual motion of the mass. Using the calibration stick, I defined the distance between the fixed attachment point and the center of mass as 0.7 meters. I also set the time between images in the video to 10.5 seconds, and the mass is on the negative y-axis. Then I found the frame where the mass was about to move, frame 5, and I found the point mass for each frame, starting at 5 until the end of the video. In order to find the spring stiffness, I used the equation for period, which is the time needed for a complete oscillation of the spring to occur. I used the time for 3 periods from the Tracker graph and found t, which is 1.524 seconds, and then solved for the spring stiffness k, which is 6.83 newtons per meter. Moving into the code, in order to find the relaxed length of the spring mass, you set the gravitational force equal to the spring force because they are at static equilibrium. The relaxed length is 0.123 meters. Moving into the code in Python, I set the initial conditions. The mass is 0.402 kilograms, the initial position of the ball is 0.6299, and in the x direction, and negative 0.1108 in the y direction. I also put the conditions for the gravity constant, spring constant, and relaxed length into the code, as well as the equation to calculate the spring force. In the calculation loop, I made t less than 9.524 seconds because that was my final time. I defined the initial energies and equations to calculate the spring, gravity, and net force. Newton's second law is also defined to predict the new velocity and position. Then I defined the equations for the heat principle. Kinetic energy is equal to 1/2 mv squared. Gravitational potential energy is equal to mg delta y. And the spring potential energy is equal to 1/2 ks squared. This is the model produced. The blue arrow is the spring force and the black arrow is the force of gravity. The ball springs up and down in the y direction and oscillates left to right in the x direction. The blue dot represents the predicted data and the red dot represents the actual data in Tracker. The model represents the data well, but is slightly off because of error when finding the point mass. This graph shows the energies in the system. The blue is kinetic energy, red is spring potential energy, green is gravitational potential energy, and the yellow is total energy. Notice the total energy of the system is 0. This means the energy principle is satisfied. Because the mass, spring, and earth are all included in the system, there is no surrounding forces and thus no work and no change in energy. Energy is conserved. When estimating the oscillation periods of the spring mass, the period is 1.524 seconds in the x position and 1.27 seconds in the y position. The two periods are different because of their values. The x direction is based off of the length and gravity, while the y direction is based off of the mass and spring stiffness. The oscillation period is greater for the x position, meaning the spring mass moves more in the x direction than the y direction.